take a look at this. You guys tell me if there's any questions. Work off your core graph. Again, if you struggle with finding where your shifts are and what they do to your domain and your range, put your original domain and range out there. Right now, nothing's going to affect your domain. What will affect it is a shift in your Y, either way in your Y, or a reflection will affect your range. So you guys tell me if you had any problems. The Y-intercept right now, plug X in for 0. I don't expect you to find the X-intercept if you don't use your calculator, because that would require a log to bring that exponent down. But you can use your calculator if you like and do a zeros and find it if you like. It just kind of helps with your placement, but most of this I kind of wanted you to try to do without the calculator. Check it on your calculator, make sure you know where it's going, and if you wanted to do your X-intercept, that's fine. Today we're going to work with the calculator, with applications, and do a lot with your windows and find these things on your calculator. Okay, again, do your reflection first and then do your shift. Okay, I think this is important if you do it in the right order. So make sure you do it in the right order. If you did the shift and then the reflection, it's going to look a little different. So follow order of operations when you do this. Everybody good? Good. I'm not going to spend a lot of time. Just tell me if you have any questions, and we'll go over that part. This one had a horizontal. I think that's a +3. Yeah, it must be a +3. X +3 means it's shifted horizontally the opposite way. That went left 3 and then down 2. If you want to keep track of your 0, 1 point at the same time, this way you kind of keep a perspective on where am I putting this thing. It just kind of helps to keep track of 1 point. And if you do put it in your calculator and you check it, that point should be on your graph. Okay, a negative X +1. So there's a reflection, there's a horizontal shift, and then there's a vertical shift. The vertical shift is going to change your range. So be careful about your range. You still good?
Wait. I'm sorry, I was a little slow.
That's okay.
Okay, yeah. Sorry about that.
You're fine. You're fine. I don't want to go too fast if you need help on this. Again, in the exponent up there, take out a -1 and turn it around. Probably makes things look a little bit easier. You could take a -1 out of the other one too. That would work. But this guy probably makes more sense if you at least switch them around, -x +2. I like to do my transformations piece by piece. I like the sketches, especially on a test. I want to see your sketches about what's happening to each transformation.
Oh, you do?
And then your end one.
You want to see each one of the transformations?
Yeah.
Oh.
Yeah.
What does that say? Sorry, excuse me. Right under the equation or the function, what does it say?
Am I here?
No, over. Yeah.
Here? You could write it this way or this way.
Oh, okay.
Yeah. Which probably makes it easier to work with.
Right. Oh.
So you're still reflecting. That negative causes you a reflection, and this negative in here causes a shift to the right.
Okay.
This one out here causes the reflection over the x-axis, and then lastly a vertical shift up 4. So you got to be careful of your order. And if you want, put it in your calculator step by step just to see what each piece is doing. It kind of will help you out that way too. Are you guys okay with these? Plugging them in? Remember, you have to know that formula. N is compounding. Compounding how many times a year? The N's going to change. The R. Be careful of your rate. Your rate has to be in a decimal. 4% is 0.04. And again, round your money to 2 decimal places. Okay?
You usually have to put the $ on it.
You should. I'm not going to take points off if you didn't, but It's money. You should. I don't always remember it either because you're usually just like subconsciously just doing the math.
If there's a word problem, I'd probably
A word problem makes probably a little bit more sense because we don't have the original dollar sign out there for the principal, but this is your money. Yeah. E means there's your E, so you have to use per. Okay, and I didn't give you that one. Are we good so far with this? Okay. All right. So let's start simple. Some of them they make sense, they fit right in, and some of them will have to use your calculator for. All right, so we want the value of an initial investment. Here's our initial investment of $2,575 at 8%. This is our rate, and here's where we're compounding continuously for 6 years. This is my time. Okay, so per. So what gave per away? Continuously. So right away, you're going to do per. A, when we do this, this stands for the accrued value. This stands for what did you make after investing this principal at that rate for so many years. And yes, we can plug all the pieces in just like you did for homework. Some of them are going to be nice and simple. You don't really even need that. Okay, some of them you can plug in. Some of them we're going to have to use your calculator for. Right. Now, I want you to remember too that I put this in parentheses so that you remember this goes with the E only. It doesn't go to the 2,575. That goes to the E only. Okay? So again, you can plug this one into your calculator. This one works kind of nice, just like you did for your homework. And you should come out with $4,161.39. 8% again is probably a percent you will hopefully see in your lifetime, but I doubt. But we use the bigger percent so that we could see a drastic change in our numbers. If we use the percents now, you would hardly see any change. Okay, so some of these you're going to put right in, and some we're going to do with your calculator.
What's a normal?
A normal percentage is probably,
Is it like a decimal?
yeah, it's less than 1% right now.
Oh, really? That's cheap.
Yeah, sometimes they'll do a CD like 2%. They'll make it like a really enticing one, but you have to put like a certain amount in there and leave it for a certain amount of years.
That's crazy.
Yeah, it's no longer,
It's a way to make more money.
well, the banks have to make money, I guess. I'm going to leave that one because you can do that one. So let's take a look at number 3. Determine when an investment accumulates to a value of $1,500, accumulates to a value of $3,750 if the investment earns interest at a rate of 8% and is compounded monthly. Okay, so let's take a look at this one. I don't think I have this one. Is this the one you guys have?
Yeah.
Okay. Because I changed these.
Number 3 though.
Not your 3?
She said we're skipping 2.
We skipped 2. 2 you can do. I want to hit one where you're not going to be able to.
Yeah.
So it's not saying how many months at most we don't know? Or how long it'll take?
So what is it they're asking us to find? T. Determine when. Okay? So we're going to have to use your calculator for this guy. Because we're going to have your variable in your exponent. So let's plug in what we know. We want it to reach this value. We want to invest this much money. We're going to fill in everything that we know. We know your rate. Flip it to a decimal. How many times is it compounded? 12. And what should my exponent be? 12t. Okay. Now, algebraically, you can't find this. Algebraically, you can't find this. Well, you probably can. You know your logs, but we haven't done your logs yet. So what we're going to do is put this in your calculator. We're going to put this in, and we're going to look for time.
But what about 37?
Well, how could we find where they intersect? We plug this into y2. This is going to go into y1, and that's going to go into y2, and we're going to see where they intersect. Now we're going to have to play with your windows a little bit here.
Always fun with the windows.
Always fun with the windows. That's where we have our most fun.
I wouldn't go that far.
Really? Okay, and in the second one, we're going to put 3750. Now, obviously when we graph this is not happening on our little 10 by 10. So let's take a look at our window. Oops, still working here. Okay. What should my mins be for my x and my y? 0. Why is that?
Because you can't have a negative interest.
Good. You can't get a negative time or a negative accrued amount. We're talking time on our x and our accrued amount on our y. Now, let's estimate. How many years do you think this is going to take?
Maybe we can go 20.
Okay, let's go 20. My y max. What should my y max be according to this equation?
Over, well, 3750.
3750 is where I want to match them, right? So I'll just go maybe 4,000, 5,000. If that's not going to matter, I can put 5,000 in there. I want to see my graph grow. Look, my money's growing. There's my money growing.
Better than it going the other way.
Yes, there's my 3750. And I want to see when that represents my x value, when I reach that amount. How do I find where they cross?
We have to go second calc.
Second calc, intersect, there you go. First, second, guess. So, my x value says, remember 3 decimal places, x equals 11.492 years to reach 3750.
Can't you simplify it to not do the linear? Like if you do 3750
And divide, we can, but right now I just want to look at it this way, and we usually do that if we're doing a log, if we're actually doing a log statement, we usually do that with a log. I really don't like to do that unless it divides in evenly, it terminates. It's not good to do it if it doesn't terminate, then you have to leave it as a fraction anyway.
Nice.
Okay? All right. So we can kind of figure that. So what I'm looking for is time, money. This is how much you earn. And we're going like this, and we're crossing right here. This is how you're going to show me your work.
Oh, you want us to sketch it?
Yep. It's a simple little sketch.
I
Doesn't
just
require a lot.
wasn't sure.
Good? All right, let's try another one. Always fun. Determine when an investment doubles in value at 6%. Well, we know it has to be when. We know we're looking for time. We have to double. We're 6% rate, and we're compounding continuously. Yep, there's your curve. So I'm going to work with this equation. Again, I need to know my time, so I'm going to need to graph this. So what can I fill in? They didn't give me an amount.
Simple numbers.
Simple. So give me a simple number.
Well, do you want to go small or large simple numbers? We can go 2 and 4.
2 and 4. So let's see what happens here. So let me show you something. Now, Rohan also had a little suggestion before. Why don't we divide it and make it even simpler? So why don't we divide this and make it even simpler? What does this come out to be?
Oh, wait.
Can I use 2 to 1? I obviously don't need the 1, but can I use 2 to 1? Mm-hmm. Isn't that doubling?
Mm-hmm.
What would tripling be? 3 to 1. Could I use 200 to 100?
Yeah.
Absolutely.
I think you're making yourself.
You can use anything that you want in there as long as you show doubles. 2 to 1 is a very good one to put in there. Okay? And you can kind of see right away, oh, you're doubling. So let's put the rest of this in. We know E, we know our rate, we don't know our time. So let's put this back in your calculator. We're going to have to change your windows again because we had some really, really large numbers in there.
Yeah.
Wait, it's all in years, right?
In years. Mm-hmm. It should say determine when in years, but it doesn't. What's your interest rate? 0.06. Oops, I wrote 0.08. And what are we going to put on Y2? If I use 1 in Y1? 2. So let's go back to a zoom 6. And let's reset our Y values, our mins. We're always going to start at the zeros. Let's see what this looks like. I'm not sure if it intersects, so what can we change to make sure that we see where it intersects?
X max.
The X max. So double your X max. It even makes my graph look a little more like it's growing. Okay. Just make sure that you can catch it in your screen.
Wow, that's great.
Okay. So again, we would catch this at 11.552 years. I would double my investment. So again, don't we look very similar? We're growing. We doubled. And where do we meet? You can also go to your table to set your windows, but usually your money kind of gives you a good idea of where it is you're going. Okay? Questions?